Welcome to C# for Crestron programming. In this video, we will learn about the basics of delegates in C#. We will see how they can assist in selecting the method to run and in sequencing method execution. We will be starting with a C# console app.NET framework project called Delegates. We have declared and initialized a global static variable called result, and have declared several methods to perform operations on this variable. All of the methods declared have the same signature, meaning the same return type of void and no parameters. At a basic level, a delegate can be thought of as a container for a method. Just like a physical container for anything in the real world, the thing to be contained must match, or at least fit into, the container that will be used. Our delegate declaration will be set to match the signature of our example methods. Delegate void mathDelegate with empty parenthesis. Why would we need a container when these methods can be accessed or run on their own? A delegate can be used in your code as a dynamic placeholder for whichever method you need to assign. While in our tester example it appears as though we are running the delegate itself as a method, the delegate is passing the request to run onto the original method. At any point, we are able to reassign the method called by the delegate. Delegates also allow us to perform cascading operations within the single delegate invocation. If we create delegates for each method to be used and assign them to another delegate of the same type, this creates a multicast delegate. Comment out the tester delegate to start our result variable at 0 for this section. It seems we have excluded one of the operations required. To add additional operations to the multicast delegate, we can simply edit the original assignment, or use the += syntax to add additional operations. The order in which the methods are assigned within the multicast delegate can also be critical for operation. Here, we are adding methods directly to the delegate to create a multicast delegate. We do not need to assign them to their own delegates before adding them to this multicast delegate. While there is increased clarity in this format, we do lose some additional capability. This line of code is not valid. In our console WriteLine method, we are using a ternary operator to determine if result equals to 10 and that bed mass has been followed. In the output window, we see the result is 16. Therefore, order of operations has not been maintained. If we wish to view the order of invocation of the methods, there is a built-in method within the multicast delegate class called getInvocationList. Here, a basic for each loop will reveal where we are going wrong. In order to fix this issue, we need to remove the method add_to from its location in the list and reinsert it at the end of the list. As this list is first in, first run, we simply remove and re-add the method to move it to the end of the list. As a side note, since we already have a delegate that matches the method of add_to, we can use it in place of the method name at our convenience. We can see in the output window that the order has been corrected, and our output follows the bedmass rules. You have now seen how to declare a delegate and assign a method with a matching signature, how delegates can be used to dynamically assign different methods, and how multicast delegates can be used to chain method execution together. Thank you for watching.